Hello students, welcome to the lecture of structure of atom. Till now we have studied about Rutherford's nuclear model of atom, and in the last lectures we have discussed about atomic number, atomic mass and different types of relations between atoms like isotopes, isobars, isodiaphers, isotones and isoelectronic species. We had started about isospheres, but some discussions are left. So, we will first discuss about isospheres and then we will move forward. So, before starting isospheres, let's have a quick check on what were the previous topics. So, atomic number, which was represented by Z. What is atomic number? That is the number of protons. For neutral atom, number of protons will always be equal to number of electrons. And what was mass number? Mass number is denoted by A. Mass number is the sum of number of protons and number of neutrons. So, number of protons plus number of neutrons. Okay. So, for example, this is a compound like nitrogen with atomic number 7 and mass number 14. So, it is denoted like this, the symbol of the element with atomic number at the bottom and mass number at the top. So, for nitrogen, 7 is the atomic number and 14 is the mass number. So, after that, we had discussed how various elements are related. First one was isotopes. What were isotopes? For isotopes, they were same element, that is same atomic number but different mass number. So, basically the difference was in the number of neutrons, like 3 isotopes of hydrogen, deuterium and tritium. For all of them, atomic number is 1 and for all of them the mass number is different, right? So, these are isotopes. What were isobars? Isobars were different elements. Isotopes are always the same element. So, they will have same chemical properties but different physical properties, and they also may have different reactivities. For isobars, isobars were different elements which had same mass number but different atomic number. Okay. So, some examples of isobars were like nitrogen and carbon 14. Why? Because the most common atom of carbon has a mass number of 12, but carbon 14 is an isotope of carbon which is isobaric to nitrogen 14, that is they have different atomic numbers but same mass numbers. So, these are isobars. Next, we had studied about isodiaphers. What were isodiaphers? That is same difference between numbers of protons and neutrons. So, one example is fluorine with atomic number 9 and mass number 19, and sodium with atomic number 11, mass number 23. So, what is the relation? For fluorine, number of protons is 9, number of electrons is 9, and number of neutron is 19 minus 9, that is 10. For sodium, there are 11 protons, 11 electrons, and neutron is 12, right? So, for fluorine, what is the difference between number of protons and number of neutrons? We write this like this: mod of neutron minus proton, that is, it can be positive or negative. That is, the number of neutrons can be greater or the number of protons can also be greater. So, for fluorine, this is 10 minus 9, that is 1, and for sodium, it is n minus p equal to 12 minus 11, that is 1. So, the difference between number of proton and neutron is same. So, these are isodiaphers. The next one was isotones. Isotones is elements with same number of neutrons. Okay, so like tritium and helium. Okay, tritium has one atomic number 1 and mass number 3. So, proton is 1 and neutron will be 3 minus 1, that is 2. And for helium, proton is 2. So, neutron will be 4 minus 2, that is 2. So, for both of them, number of neutrons is 2. So, they are isotones. So, the next one was isoelectronic species. What are isoelectronic species? So, of course, it is very obvious from the name. Isoelectronic species means different atoms, molecules or ions with same number of electrons. So, this can be molecules or ions also. So, what are ions? Ions are positively charged or negatively charged species. That is, if one atom accepts electrons, okay, accepts extra electrons, then they have a negative charge. These are called anions. Since electrons are negatively charged, so addition of electrons will form a negative charge on the atom. They are called anions or negatively charged ions. And when atoms liberate electrons, that is, they give away electrons, so negative charge is decreasing, so they develop a positive charge. These are positively charged ions or cations. So, ions and molecules can also be isoelectronic species. One such example is Na plus and Mg2 plus. So, what is the atomic number of sodium? It is 11. Okay, so if Na plus means 1 electron goes out, so 10 electrons are left. And for magnesium, the atomic number of magnesium is 12. So if 2 electrons go out, that is 2 plus. So 12 minus 2, that is 10. So both of them have same number of electrons. Some molecules can also have same number of electrons, like H2O, that is water, and methane, CH4. So here hydrogen have 1 into 2, means for 2 hydrogen atoms there are 2 electrons, and oxygen have 8 electrons, therefore 10 electrons. And for methane, carbon has 6 electrons and 4 hydrogen have 4 electrons, therefore 10 electrons. So water and methane are isoelectronic species. So next, the discussion that was left was isosters. What are isosters? They are molecules which have same number of atoms and electrons. Okay, so the number of atoms and electrons both will be same. So let's do an example, that is calcium oxide, CaO, and potassium fluoride, Kf. So what is the number of atoms? Calcium and oxygen, that is 2, and here also 2. So the number of atoms are same. Now what is the number of electrons? Calcium has an atomic number of 20, that is calcium has 20 electrons and oxygen has 8 electrons. So it is 28, and potassium has 19 electrons and fluorine has 9 electrons. So it is again 28. So both of them have 2 atoms and 28 electrons each. So they are isosters. Another example is NO2 minus and O3, that is ozone. So here atoms, here also 3 atoms and here also 3 atoms. Now the number of electrons. Nitrogen has 7 electrons from nitrogen. Okay. Oxygen, there are 2 oxygens. So 2 into 18, so 16 electrons from oxygen and 1 extra electron from the negative charge. So that makes 24 electrons. And for ozone, there are 3 oxygen, so 8 into 3, that is 24 electrons. So they are isosters. So we can do some other examples also, like let's see CO2 and N2O, carbon dioxide. Okay, so number of atoms, carbon has 6 electrons and 2 oxygen atoms will have 8 into 2, that is 6 plus 16. So carbon dioxide will have 22 electrons and nitrogen has, okay, so here number of atoms is 3 and electrons, nitrogen, 2 nitrogen will have 14 electrons and oxygen will have 8 electrons. So total 22 electrons. Okay. So there is a statement about isosteres and isoelectronic species. So isosteres have atoms, same number of atoms and electrons, and isoelectronic species have same number of electrons. Isoelectronic, same number of electrons, and isosteres have same number of atoms and electrons. So can we say that all isosteres are isoelectronic species, right? Because isosteres have same number of electrons. So all isosteres are isoelectronic species. But the reverse is not true, because isosteres have same number of atoms. Isoelectronic species may or may not have same number of atoms. Like, for water and methane, they were isoelectronic species, right? But in water, how many atoms are there? 2 hydrogen and 1 oxygen. So 3 atoms. But for methane, there are how many atoms? 1 carbon and 4 hydrogen. So 5 atoms. So the isoelectronic species may or may not have same number of atoms, right? So we can write, but all isoelectronic species are not isosteres. So all isosteres are isoelectronic species, but all isoelectronic species are not isosteres. So we have studied about different types of elements and their relations between them according to the number of protons, neutrons and electrons. So till now we were discussing Rutherford's model of atom. But Rutherford's model had various drawbacks and developments were made later. So next we will study about the drawbacks of Rutherford's model. Thank you.